So today we're going to look at the factored form of a quadratic relation. What we did last day is we looked at the vertex form, and that is this equation here where it goes y equals a bracket x minus h squared plus k. All right, so now we're going to look at the factored form, and eventually we'll get to another form called the standard form. But for today, it's the factored form. All right, so what I would like you to do is I would like you to get out Desmos, and I want you to go through and put these equations into Desmos, and I want you to write, as you're graphing them, which way is it opening? Is it opening up or down? Where the vertex is located, and the zeros. Zeros is another way of saying x-intercepts, okay? So I want you to get comfortable with zeros, x-intercepts, and later on I'm going to teach you roots as well, so they all mean the same thing. So what you want to do here is that you want to write down the zeros, like so for this example here, if I say write the zeros down, you will write in x equals -1 and x equals +5. Okay, so those are the zeros for this specific graph here. So I want you to go through in Desmos, plot these, plug in the equations, and then just fill in this table. Does it open up? Or down, and then the vertex and the zeros, okay? And then I want you to see if you can make a conclusion. All right, I'll show you a quick demo again if you can't remember how to use Desmos here. Okay, so I want you to just Google DESMOS, Desmos. Okay, click on that, and then it'll say graphing calculator. Yep, just click on the first one there. And then it'll take you right to the graphing page here. All right, so again, right in this part here, this is where you're going to write in the equation, and it'll instantly graph it for you. So I'll take the first one here, y equals bracket x minus 3 bracket x plus 1. So again, Desmos is smart enough to know that even if you don't type in the y equals, you'll be fine, but if you want to, you can. All right, so again, there's a keyboard at the bottom here. There's a keyboard right here that you can click on to make it easier if you're using a phone and so forth to type things in. Otherwise, if you just want to type it in with your keyboard, that works. Okay, so I quickly wrote in the equation that I have here for A, and then I'm looking at the graph here and instantly graphs it for you. So I want you to analyze things like where are the zeros? Okay, so here it is. If you hover over it, it'll tell you -1, 0, okay, 3, 0, and then the vertex here is 1, -4, and then we know that it opens up. I placed in the information here. Again, if you prefer to write the zeros as coordinates, you can do that. So if you wanted to write this as -1, 0, and the other one 3, 0, then that's fine as well. Okay. All right, but just be able to write it both ways. So we're going to be, I guess, looking at it more like this today. So just understand we're talking about the same thing. So here's the point coordinate form. Here's a way to write the zeros, okay? All right, so go ahead and do that with the rest of the equations here. And again, be careful with, putting in this 1/2 properly. Don't forget the negative here, the -1/2, etc., and the brackets and so forth, okay? So just stop the video, just go through, and then check your answers. So I've gone through and I've plotted all these different graphs in Desmos. So if you take a look here, here's the first one that we did together already and looked at. So so you can easily find where the x-intercepts are, or the zeros, so -1, +3. Okay, so there they are in this graph here, or in the table. Okay, so then, you go through and graph them all together. Here's the blue one. Okay, matches the second graph. So again, here, I'll just turn them all on. You can see that one opens. There's the next one. Okay, there's that one, and the very last one, there it is. Okay, and again, here's the first one. So yeah, so with Desmos, you just click on the colored circle here, and you can turn them on and off. So if you want to see them all together, or you want to see them one at a time, or just compare a couple together, you can do that, okay? All right, so again, very handy tool, always have it there to use whenever you need to check a graph really quickly. Okay, and before looking at the notes below, I want you to analyze the information that you found using Desmos, and try to make a connection with the equation. Okay, so what are you noticing about the equation, and what are you noticing about, say, the way that it opens? Okay, so you're looking at all these ones, they all open up, these ones all open down. What are you noticing about that pattern there? Okay, so these last three are down, these first three are up, but what's the pattern here? Oh, here's the negative here. Whenever it has negative in front, it opens down. Okay, I think we've seen that before anyway. And then if it's positive, it opens up. All right, we'll come back to the vertex in a second, but the zeros, what are we noticing about the zeros? Okay, so we have x minus 3, x plus 1, and then what are we noticing about the zeros? Okay, so we have negative 1 and positive 3. Okay, here's this one. You have negative 2, positive 2, same thing, and we have a minus 1, plus 3, but then we have a negative 3, positive 1. Here it's positive 3, positive 1, negative 3, negative 1. Okay, so hopefully you're seeing here that it's the same number, but it's the opposite sign. Okay, I know it's tricky to see when it's like they have the same number, but when they have different numbers here, you have negative 1, negative 5, positive 1, positive 5. Positive 3, positive 1, negative 3, negative 1. And then here, if they have, different signs here, so negative 1 becomes positive 1. Positive 3 plus 3 becomes negative 3. Okay, so you could see that the opposite sign, you can predict the 0 by looking, just taking this number and using the opposite sign. All right, the vertex is a little trickier. So I want you to kind of look at the numbers here, and then remember how we were learning from before whenever we had a couple points across from each other. Okay, if we looked halfway across, okay, if we looked halfway between negative 1 and 5, it's 2. So that point there is where the axis of symmetry line would go through. Okay, so if we take halfway between these points here, we'll find the x value of the vertex. The y value we'll find, by using the equation, but we can find the x value of the vertex. So if we're taking a look here, we have negative 1, and we have, negative, so we have a minus 3 plus 1, which is the same as negative 1, positive 3. So we have a negative 1 to positive 3. So halfway between those two values here is positive 1. Okay, and that's what we're noticing here. So halfway between negative 2 and positive 2 is 0. Halfway between these, negative 1, so forth. Halfway between 1 and 5 is 3. So we're finding that if we find, halfway, so just add them and divide by 2, we'll find the x value of the vertex, okay? And then from there, we should be able to find the y value of the vertex using the equation. But again, we'll do some questions like that and you'll see what to do. All right, so here's a summary. What did you notice? Okay, so whenever a, the value in front here, is positive, it opens up. And if it's less than 0, negative, it opens down. Okay, the zeros are located inside the brackets, but you just have to put them into the opposite signs. And the x value of the vertex is located at the midpoint of the zeros. So if you find halfway at the midpoint between the zeros, you will find the x value of the vertex. All right, so now we can get to our new form here. So all of these equations here are in the factored form, okay? Again, you remember seeing our vertex form, you know everything about it, how to find the vertex, the a value, all that stuff. But now we're moving on to a new one where it looks like this here, okay? All right, so we don't want a to ever be 0, so that's not, you can't allow that because then it'll just be y equals 0, which will be a straight line, okay? So we need, so if a is greater than 0, it opens up. A is less than 0, it opens down. And then other factors of this equation, you will find that the zeros are located right here, okay? But use the opposite sign. Okay, and again, yes, we're going to get to the standard form in a bit. So, but you've actually seen this form. You've been using it to factor and so forth, but for now, we'll just leave that there, okay? So factored form, you should know the vertex form, okay? And we'll get to the standard form eventually. All right, so let's move on to some examples here. So I want you to just start off with, now that you see the pattern and kind of the connection here, can you quickly find the zeros of these equations without graphing them in Desmos? Okay, so take a look here. and just go through and complete them. Let's start with the first example here by trying to determine the zeros. Okay, so again, zeros are the x-intercepts, but we're going to do this without graphing. We're just going to analyze the equation here. So we have we're looking at the values inside the brackets. So what we learned from our investigation from above, we can just pop out the opposite, the number with the opposite sign. So here, this will become x equals +1, okay, and this one will become x equals -2. Okay, so that's a nice, quick, easy way to find the zeros. I'm going to just show you another way in like how to solve for the zeros, okay? So the reason why I want you to learn this method as well is that sometimes the factors here are look a lot more complex here. So like here, 3x + 1, 2x -1, you can't just pop out just like the second number you see. You have to take into account the number that's on the x as well. So here, when the x is just x, there's just a 1 in front, you just pop them out. It's nice and easy. So again, zeros here. That's another term for the x-intercept. Okay, so if you look at this visually, here's the x-axis, and then the x-intercepts are always on the x-axis here. So if you look here, they're always on the x-axis, so the y is always equal to 0 here. Okay, whenever you find the x-intercept, y is equal to 0. Okay, so that's why when we're solving for 0, we can make y equal to 0 like that. Okay, and then I want you to solve for 0. So how you're going to do this right now is, well, I'm going to, there's, like I can't, there's nothing added or subtracted, there's just some brackets here. So I can take this and divide it away on both sides. Okay, that's allowed. And then what happens when I do that? Well, these ones will cancel out, and then anything divided by 0 becomes 0. So then I'm left with this, and I'll just drop the brackets now. Okay, and then from there, if you solve for it, you boot the 1 over, it becomes positive. So x is equal to 1, and there we go. We found our first 0. Okay. All right. So now we could do the same thing, but we'll do the opposite. Instead of taking out the x + 2, we'll take away the x - 1 instead. Okay, so we'll divide it on both sides. So it's like, think of it as like you're booting it over here. Okay, so they're multiplied right now. I'm going to boot it over here, so that means it'll divide over on this side. Okay, and then that leaves an x + 2 here. Okay, so 0 divided by this becomes 0, and then I have x + 2 left. Okay, and then I'll check it over. That becomes -2. X is equal to -2, like that. Okay, so we found our two zeros, aka x-intercepts. Okay, but yes, we used a really complicated way of finding them, I guess you can think of it, but I just want you to have this to fall back on and understand why, we're just taking these numbers and popping out the opposite, okay? It's because we're solving for the x value here. So the value that would work in here is x equals 1 and x equals -2. Okay. All right. So when they're simple like this, yes, just save the time, do this. But when we get to ones more complex like that, that's when I want you to have this method to fall back on. Okay. Okay. So what you're noticing here is it's a basic x - 4, right, expression here, and an x + 2. So here you just pop them out. So you go x is +4, and then this one, x is -2. So nice and easy. There are your zeros. Okay. All right. But here, this is the issue here. We have something more complicated here. So you can't just pop out like, oh, the answer must be 1 and -1. No, you have to take into account the fact that there's a 2 and a 3 involved as well. So what did we notice here? When we went through this method here, we canceled out one of the brackets and then equaled the other bracket to 0. Okay, so that's kind of what you're doing here and then solving it. So we can even jump to that step instead of writing all of this stuff out here. So here, if we're just trying to find that one, we can just go that one equal to 0. Okay, and then so if you solve for it, okay, so kick the 1 over, make it -1, and then divide this 3 away. Okay, so we moved the 1, made it -1. Now we're going to move the 3. So since it's multiplied, we're going to divide it away. So there's your first 0. Okay, now let's do the other one here. So we're going to go 2x minus 1 equals 0. Okay, so same thing. Boot this over. Boot the 2 over. And then there's your other 0. So the zeros for this one, it's not, -1, +1. It's actually -1/3 and +1/2. Okay, so again, this is a way to solve for it. If you prefer to just kind of go, okay, I know I need the opposite sign, and then I'll just move this 3 underneath. I need the opposite sign here, so positive, and then just move the 2 underneath. That's another way some of my students do it as well. Okay, all right, so but either way, in the end, you're getting the same x-intercept here. Okay, so those are the ones to watch out for when they look a little bit more complicated in the factor part here. But if they're nice and easy where they start with an x and nothing else is on the x, then you just pop them out, okay? Pop out the opposite side. All right, let's move to the last one here. Okay, so again, don't, with this one here, see how there was a negative? It didn't affect the x-intercepts, okay? Remember, the negative is just determines if it opens up or down, but it does not affect the x-intercepts. So here's another negative, same thing, it's not going to affect the x-intercepts. But even this 2 here, that just determines if it stretches or compresses and so forth, right? But in this case, it would be a stretch. So again, it does not affect the x-intercepts. So don't worry about the fact that there's a number in front. It's more what's inside the brackets here, okay? So I'm seeing that this x plus 1 here, right? That's a nice simple one. So, I could just pop out the opposite sign, -1, okay? But this one's a little more complicated. So that's the one I'm going to solve for. So I know I can equal to 0. Okay, chuck the 3 over. So again, if it's a minus, it has to be the opposite sign. It should be a positive. Boot the 5 over, 3 over 5. Okay, and there is your other x-intercept. That's a little more complicated. Okay, so again, I know we were graphing them here on Desmos, and they were really nice, like x-intercepts, where they were nice integer values. But yes, you can end up with these fraction values as well, okay? So that's why it's good to be able to solve your way through them instead of just using, you can't always use Desmos because, well, it'll, and like if it's a fractional value like that, it's a little trickier to find that by looking at the graph, okay? All right, so now that you hopefully are comfortable finding the zeros, I want you now to find out some more information about the factored form. Okay, so if I give you the equation here, you should be able to now determine all of the stuff that you've been doing before, like which way does it open, what's the axis of symmetry equation, what's the vertex, etc. Okay, and I want you to be able to do this without actually graphing it. So you should now be able to look at the equation here and determine all this information without graphing it in Desmos first, okay? So go through, fill it out, and then use Desmos to double check your work. Okay, so we'll look at this next example here. So now, now that if I give you guys a factored form equation here, you should be able to find all this information without graphing it in Desmos. So for the direction of opening, we always look at the A value in front, and if it's positive, we know it opens up. Okay, all right, and the zeros, we have some nice simple factors here, x minus something, x plus something. You don't have a number multiplied to x, so we just know we could pop out the opposite sign. So we got -1 and +5, like that, okay? All right, so another way you could write those, you could write that and then write and this one, okay? But don't write it this way, where you're like, oh, just listen them off like this, because that looks like a point coordinate, and it's not clear what it's not clear what your thinking is and so forth. So just write and or a comma in between, and then write an X with both of them, okay? All right, so don't do this one. All right, so then from there, so if we were to just make a, like we can even add it on here. So we know the x-intercepts, one's at -1, one's at +5. There it is. We know that it opens up, so we know that the graph will go this way, and then like the bottom will be here somewhere. So what did we notice from graphing it in Desmos over here? Well, whenever we have our two intercepts here, the axis symmetry is right through here, and what does the axis symmetry do? It always goes through the vertex. Okay, so if we were yeah, so that's how we'll do these next two here. So for now, like the axis symmetry should be halfway between where the zeros are. Okay, so right here, halfway between those points. So what we're going to do is we're going to just calculate halfway here. And then our equation should have the form x equals the number, okay? All right, so if we take -1 and we add +5 and then divide by 2, we will get 4/2, which is equal to 2. Okay, so now write it all together simplified. The axis of symmetry equation is x equals 2. Okay, so we can even plot that on our graph so we can visualize this better. Okay, so there we go. So it's halfway between the x-intercepts, or the zeros, okay? All right, so what did we notice about the vertex? Well, so the axis of symmetry always goes to the vertex. So there's that one. I can turn on a different one here. So axis symmetry, there it goes. It hits the vertex, okay? So again, without graphing it, how would we go about finding the vertex? So again, we know the vertex has the form like x, y, like a point like that. So we know that the axis of symmetry of 2, right? X equals 2. It definitely goes to the vertex. So far we do know the x value of the vertex. Okay. All right. So how do we find the y value? Well, we've done this before in other cycles. You have an equation here. So you're going to use that equation, plug in the x equals 2 into the equation, and then solve for y. Okay, so here is the equation I'll write out. Okay, and then I want you to plug this 2, because remember it's the x, right? Plug it in here. So 2 plus 1. And then yes, you're going to plug it into a couple places here, because I know you're used to when it was linear, you just plugged it into one spot. But yeah, you plug it into both here. Okay, and then clean up brackets first. Do the brackets, 3, -3. Okay, and then exponents, nope. Okay, multiply and divide. Yeah, multiply these together, and you get -9. Okay, so you just found your y value of your vertex. So here, write your vertex now. It's 2, -1. No, 9, sorry. All right, so if you're to plot that on here, 2, 4, 6, 8, 9, right there. There's your vertex. Okay, so you could start, plotting it, or graphing it, but I'll just wait for a sec. So we found our vertex, we found our axis of symmetry equation. Okay, and it all was built on the fact that we knew the zeros. Okay, and we found the zeros correctly. We knew which way it opened, so we know which way our graph will open, and so far it's looking good. All right, optimal value, remember, this means your maximum value. Okay, so again, get comfortable with that terminology. Sometimes I'll say max, find the maximum or minimum, or I'll say find the optimal value. So in this case here, we're looking for the value of the max or min. So hopefully you see that if the vertex is down here, it opens up, you know that we have a minimum, right? And it'll be at, how low did it go? It went to 9, okay? So we know here, okay, so we know the value is 9, and we know that it's a minimum. Okay, because the max is up here, we can't find the max because it goes forever. All right, so from here, I know with the vertex form, I had you graphing 5 points, like the vertex and a couple on each side, because we use the step pattern. For the factor form, I'm okay with if you have the zeros, the vertex, and then just the 3 points, and then just graph it, okay? So now we'll just get a graph going here. So again, nice smooth bottom part here. Okay, don't make a V, right? And then it's more like a U there. And then the arms go out wider and wider. Okay, so it's just a rough sketch like that. Okay, all right, so yeah, like when you're handing in your checkpoint today, you don't have to, put it in GeoGebra. You could just quickly graph something, show me that this point here is, this is -1, that's 5, right? And then I could see that your vertex was 2, -9. So you can make a rough sketch of this on just a piece of paper without using graph paper. And then, so from there, you're showing me clearly that you know where the important points are for the factor form. And then you're showing me that it opens up and you have a smooth curve, you have arrowheads, and you are labeling it as well with the equation. Okay, so that's all the stuff for today. Like you just have to, I just wanted to introduce you to the factored form. So you should be able to find a lot of information from it. So you can find all the stuff that we found before with the vertex form, but now you can find all of it with the factored form. All right, we'll do one more, and then I'll get you to go and practice your worksheets and so forth. All right, so starting from the beginning here, we have to determine if it opens up or down. And here, since it's negative, it opens down. Okay, and the zeros, the same thing. We have some nice factors here, simple ones, so you can just pop out the opposite. Okay, so positive 1 becomes negative, positive 2 becomes negative 2. All right, and again, if you wanted to just quickly plot it so you can visualize what you're doing. So there's negative 1. Oh, this is going to be a super tiny one. Negative 2. There they are. Those are the x-intercepts. So right from here, I'm sure you can predict what the axis of symmetry is, but I want to show your work here. You take the two numbers for the intercepts, divide by 2. Okay, and then you get 3 over 2, which is the same as, since we're graphing it, you can just change it to a decimal here so you can visualize it better. So negative 1.5. Okay, so that makes sense, halfway between these two. Okay, all right, and then the vertex. So we know so far the x value of the vertex is that. We have to find the y value, so we're going to use the equation that we have from the beginning. And you're going to plug these values in, okay? So again, I know I always tell you guys, you're an academic, you have to keep things in decimals. If you want to go through and do work, keep things as fractions, but if you want to go through and work through with decimals and then bring it back out of the into a fraction form, that's okay as well. So if you wanted to just temporarily change this to negative 1.5 like that, so you can put it in here as negative 1.5, that's totally fine. So negative 1.5. Okay, and then clean it up. So let's do the brackets first. So negative 1.5 plus 2 is 0.5. And then here, negative 1.5 plus 1 is negative 0.5. All right, and then let's multiply all those together. So we have a negative 2 times 0.5 times negative 0.5. Okay, so negative and negative makes positive. So y equals 0.5. Okay, which is 1/2 as a fraction. So if we're writing it back as fraction form, you just write it like that. So there is your vertex. Okay, all right, so what's the optimal value? I'm just going to change to a different color here because we're getting messy. Okay, so the optimal value here, so how low did it go? So it's 1/2. Okay, so the optimal value is always the y value. The axis symmetry is always the x value of the vertex, right? So here, optimal values, is positive 1/2, 1/2. Okay, and we know that it opens down, right? So it goes like this, so we know we have a maximum. All right, so let's graph these now. So we're going to put the vertex at negative 1.5 and 1.5. So this is a tiny graph. So there's the dot right there. Oh, that's horrible. Okay, and then make a good rough sketch of the graph like that. Okay, and then label it. Okay, all right, so that's all I want you to be able to cover today. Nice short lesson, hopefully. So again, you are now have been introduced to the factored form. You should know the a value kind of is the same as the a value in the vertex form, but now you have the rest of the equation looking like this, and these are the zeros. okay, which are also the x-intercepts. So you should be able to find the x-intercepts easily, the zeros. And then you should also be able to find things like which way it opens, the axis symmetry equation, the vertex, the optimal values, if it's a max or min and what value is the max or min at, and then be able to make a sketch with 3 good points, arrowheads, and label. Okay, so be able to do all of those things and you should be good to go, and then we can move on to some other parts of the factor form next day.